I hope you're all here because you are interested in some large-scale enterprise Flutter development, because for the next 30 minutes we'll be talking about how we build mobile applications at Tide, which is a UK-based fintech company providing a huge financial services platform for small and medium businesses. At Tide, we are on the mission to save businesses time and money so they can get back to doing what they love. And to better represent the scale of our product, I prepared a few stats about the reach of our mobile application. We currently offer our services in 3 countries, UK, India, and Germany. And we have recently reached a milestone of 1 million businesses onboarded on our platform. And we average about 500K user sessions on mobile devices on a busy day. And here are a few stats about our code base, which is about 3 years old. We have just under 3 million lines of Dart code organized in over 400 packages. And our team already has over 60 mobile engineers, and we keep growing. By the way, we constantly hire in certain countries, so if you're interested in joining, feel free to ping me about it. So as you can imagine, such a scale imposes serious challenges. And my goal here today is to share with you our ways of solving them so that you can apply similar techniques in your Flutter project when you are faced with similar challenges or even in smaller projects. I'll talk about the architecture, approaches, and philosophy of our Flutter application and the tools we use for development and maintenance. Of course, it's impossible to cover everything in one go, so I will be touching some topics only lightly. And also I will have to provide you with some general context about our application and the team, because without it, not everything will make sense. Since I will be basically onboarding you in our engineering team, why not imagine that you are actually joining Tide as a Flutter engineer, so welcome to Tide. On your first day, you will meet your onboarding buddy, and today it's me. I'm Anna, a Google developer expert in Dart and Flutter from Ukraine. I've been working at Tide for almost 3 years now as a senior staff engineer, and my primary responsibilities include building and maintaining the foundations of our Flutter project, the architecture and tools that allow all mobile engineers to contribute efficiently to our single code base and single product. I'm also active in different communities and online, sharing educational content about Flutter, development at scale, and developer productivity. All right, back to our Tide journey. The first thing you will get familiar with is our team structure. It's important not only because it impacts the environment you'll be working in, but also the code base. So, for management efficiency, our team is divided into a dozen of sub-teams, and this list here is not exhaustive. Each team is dedicated to a specific area of our financial platform, such as payments, credits, business and financial services, and more. As a new member of the team, you will be placed one of these sub-teams and start gaining domain knowledge in that area. But despite this segmented structure, we all are working together on a single project as one team, because we are mindful about the importance of the alignment and consistency of our ways of working, approaches, but also the code base, because it allows engineers to switch teams with minimum productivity loss. Each part of the code base has its owners, but all developers are encouraged to contribute to any corner of the project. And we all review each other's code, which allows us to align on approaches and help each other with technical challenges. Speaking of code, I guess you'd want to check out the project and run the application. We follow the Monorepo approach and store all of our Flutter code in a single GitHub repository. So to start, you'd only need to run a single git clone command. We do have all generated files and configuration files committed into the version control system. So once you clone the repository and perform pub-get, you're actually ready to launch the application. And as for the IDE, we don't have strict regulations, so most of our engineers have both Android Studio and VS Code installed and use them to their liking. We've added some IDE settings to Git as well to make it easier for anyone to get started with the project. And additionally, we have a list of recommended plugins such as Flutter Enhancement Suite, Gherkin, coverage cutters, and others documented. Now that you have the code base, you'll notice we have split our project into hundreds of small packages. And the reason for this is maintenance and performance. Think of a few typical tasks we perform on our daily development. It's running tests and potentially with code coverage to see what's covered and what is not, and running code generation. Both of these activities support watch mode, which is even more beneficial for active development. So imagine if we had only a few packages with thousands of lines of code. So running tests with code coverage or using build runner would take significant time. So instead, we split the project into smaller packages. And it turns out that in practice, we only change 1 or 2 packages at a time, which allows us to work on the huge project efficiently. And additionally, it allows us to speed up the CI checks we run on HPR, but more on this later. To simplify the decision process of what goes into a standalone package, we follow a package-by-feature approach. Each small piece of functionality, whether it is a utility or a user flow, has a dedicated Dart package. It's nice because we rarely work on more than 1 or 2 features at a time, so we don't need to touch many packages. And it's also a rare situation that more than 2 developers work on the same feature, so we have a minimum merge conflicts in our project. Overall, our code is pretty much consistent across the entire code base, and this once again allows engineers to switch teams without the need to learn new patterns and frameworks. To facilitate the creation of such unified packages, we developed a few Mason templates. They cover the creation of utility and feature packages, and as well they allow us to add some code to already existing packages. This is a great contributor to our efficiency and consistency. And of course, to manage this huge amount of packages in a single monorepo, we use Melos. We have scripts for performing pubget and running other frequently used commands, and this is another great contributor to our development efficiency. I can go on and on about how important is the code-based consistency for large-scale projects. So to take it further, we compiled a list of rules to keep our code base clean and unified. First of all of our code is formatted with Dart formatter, with the exception of generated files. Next, we have a zero analyzer warnings policy. We use a very long list of handpicked linter rules from the standard set. And unfortunately, currently we experience analyzer performance issues caused by the number of packages we have in our project. So we cannot use custom tools like Dart code metrics or custom lints to apply more strict regulations right in the IDE. And hopefully this situation will change soon with the new tools developed by the Dart team. But for now, we implemented some additional checks only on CI. To give you an example, with each PR, we check that no package imports its own barrel file or that no new circle dependencies are being introduced. And finally, we gathered all non-automated rules in a Confluence page. For example, preferred naming convention, usage of consts, recommendations for widget size, and many more. It's fine if you can't automate everything, but for such cases, it's nice to have a documented evidence of the team's agreement. And overall, we have quite an extensive documentation about our project, which includes cookbooks with step-by-step guides on how to implement certain things, motivation and philosophy behind some of the decisions, recommendations for tools setup, and other development tips and tricks. I guess we all agree that writing documentation is boring, but honestly, I'm thankful each time there is a cookbook to point to when there is a repeated question raised. And this also helps us onboard new team members faster and have a single source of truth in case of any stylistic dispute. And we're still not done with all the tools and approaches that helps us with code base and user experience consistency because we haven't yet talked about the design system. We believe it is no less important to have a unified UI than it is to have a unified code, and we aim to build an app that users don't notice that features were built by different subteams when they're using the application. So we have developed a solid design system which is based on Materials 3 theme with a bunch of extensions. We have also built a ton of controls which we called atoms, complex widgets which we call molecules, and even templates for the whole screens. And both developers and designers have to stick to the design system and reuse components for the consistent look and feel, but also because they are fine-tuned for great accessibility performance, and also they are implemented with easy support of colors change. And honestly, I believe it's impossible to overestimate the role of the design system in the quality of our product and the productivity of our team. What's interesting, we have made our design system demo available right in the mobile application through a special developer screen. So anyone with access to our dev environment can actually look through it and pick components they want for their features. So I just want to once again highlight how important are consistency, efficiency, and the ease of maintenance for a large-scale enterprise development. And we'll maximize them by keeping all of our code in Monorepo, but splitting it into hundreds of small packages and using Mason templates to make them look alike. We have automated and documented our coding style guide. We wrote a lot of documentation with an extensive descriptions of how we do certain things, and we have a design system with reusable components which are used across the entire code base. So by now you are tired about a week or two, and having learned all of that, you are expected to start contributing to our project. And for that, you'll have to watch several educational videos about our project architecture. It's a tricky but crucial aspect of our project that everyone in the team should fully understand. Naturally, the size of the team and the scale of the product and the complexity has imposed several requirements to our project architecture. It has to scale well, no matter how many features we add, and remain maintainable over time. It also has to be consistent so that developers can switch between subteams and remain productive. Our development process has to be efficient because at our scale, any small detail may lead to a big time waste. And it has to be possible to fit the architecture into one person's mind. So to meet these requirements, we created what we call the Lego architecture. Think of how individual bricks can connect together to form complex structures because they all have a universal connecting interface, right? And our code base follows the same philosophy. Each small feature in the app is wrapped into its own Dart package with only a few predefined interfaces exposed. And so just like a Lego brick, it can easily be plugged into a larger project. And now we will look inside the typical feature brick. The entry point to a feature is a full-screen widget called Flow. It's a widget that is registered inside the app navigation mechanism and is typically accessible by the deep link. And the feature itself may consist of several full-screen pages, but we consider them an implementation detail of the feature, so they are not exposed from the package, and no one can actually access them. Instead, they are all displayed inside this full-screen widget called Flow, which has its own navigator, and we use a wrapper over the Flow Builder package and implemented a declarative navigation between them. Typically, every such page would have only one purpose, and thus will have only dedicated item of state management, for which we use Flutter block. For blocks, state, and event classes, most of the time we use freezed unions. Block is the object that connects our domain logic with the UI, right? And thus, this is a class that operates with use case and repositories, which in turn then communicate with the API or wrappers over third-party dependencies. For consuming REST API, we use DO and retrofit. And for deserialization, we use JSON serializable and again freezed. Overall, thanks to the concepts like DO-interceptor and custom Dart annotations and also code generation, we created an extremely efficient implementation of the API layer. And by the way, if you're interested in all the technical details of this solution, I will be giving a workshop tomorrow morning where we will basically build the same mechanism from scratch. So I invite you all to join. Now, to connect APIs and repositories with block, we use getit and injectable package to help us efficiently implement constructor dependency injection. Also, block is where the error handling is happening. And instead of throwing and catching exceptions, all of our repositories and use cases return a special class that contains either data or exception. And this forces developers to handle both success and failure scenarios and thus have a more reliable solution. At Tide, we use our own custom implementation for that, but FP Dart and Dart's libraries provide the same functionality. And finally, I should also mention that we implement localization mechanism with i69n package. Now, how many code-generating packages you see on the screen? Yeah. So we do use code generation a lot, and in reality, there is even more packages used. And also, we created several own generators that produce code very specific to our project, because as I mentioned, our scale of the team and product, we just don't have the luxury of being inefficient and writing boilerplate code over and over again manually. So we automate as many of our tasks as possible. Let me briefly address the most widespread concerns regarding the extensive usage of code generation. First of all, we do add generated files to Git. This way we can pull the repository on a new development machine or on CI, and it is immediately ready to be used. It's in compilable state. You can run it with no delay. And thanks to the fact that our project is highly decoupled with hundreds of small packages, running code generation in each individual package doesn't take long. So all of these implementation details are actually encapsulated in a feature package, and most of the time, the only thing that is exposed is indeed the flow widget and maybe a few abstract interfaces which have to be implemented by the package consumer. We develop feature packages in a way that they don't depend on each other to simplify the dependency graph, and naturally there has to be a place where they all come together to form a single product. For that, we have a group of so-called application layer packages, which contains a navigation mechanism done with auto-route, and provide implementations for those abstract classes. Such leg architecture approach helped us build a product which would satisfy all of the requirements, which were to have a scalable and maintainable solution, which allowed our engineers to be consistent and productive and still fit in one person's mind. And this approach also helped us divide responsibilities across the team without stepping on each other's toes while working on the same code base. If you're interested in more details of this approach, overall leg architecture principles and the implementation details, check out the Writing Flutter Apps in Lego Style talk we did with Anna Leushchenko at Flutter Vikings conference. And now I intentionally left out one of the critical pieces of code we have in every package, which is tests, because it deserves a separate conversation. Naturally, it's hardly possible to build a multi-million lines of code mobile application with proper tests, so at Tide, tests are mandatory. If you were listening carefully enough, you probably remember that I mentioned 3 types of packages. We have utility, feature packages, and application, and we test them differently. Utility packages contain plain old Dart code. Thus, we test them with plain old unit tests, where one class is being tested and all of its dependencies are being mocked. They are fast and simple and almost boring in the good way. Yeah. As for the feature packages, its situation is more interesting. As a reminder, a feature package typically contains a full-screen widget called Flow, which may include a couple of full-screen pages, each of which would have its own block, which would communicate with repositories and APIs and handle errors. So which of these parts should we test and how? If we'd follow the same approach as we use utility packages, we'd have to write a set of unit tests for blocks, a separate test set for repositories, and so on. But with such approach, we would have tests tightly coupled to the implementation. So whenever there is a change request, we not only have to update a few classes, but also a few tests. And additionally, they won't cover the UI. So to address these concerns, we instead create widget tests, and through those widget tests, we test all the architectural layers together. So we create a flow widget with the real implementations of block, which use real implementations of use cases and repositories, and we only mock backend with DO interceptors and mock third-party dependencies with Mocktail. So this way, the UI is tested, blocks and error handling is tested, and even JSON deserialization is. And also, if there is a requirement change, we only need to update one test file, which covers the entire chain of dependencies. And what's also cool about these tests, they are not tightly coupled to the implementation detail. If tomorrow the team decides to switch from Flutter block to Redux or Riverport, or move from freeze union to pattern matching, or change the serialization logic from JSON serializable to a corresponding macro, no tests would need to change. So we still think of these tests as unit tests, but the meaning of unit in this case is different than in classic approach. And we believe that by thinking of the unit under tests as a piece of functionality and not necessarily a class, developers actually produce more reliable and non-fragile tests. So we call such tests feature tests, and this is the only type of tests that is allowed to create it for feature packages for efficiency. And what's even more fun, we don't just write them in Dart. Instead, we use Gherkin, which is a natural-like language with a special syntax that allows us to describe feature requirements in a way that's understandable not only to engineers, but to all stakeholders. And here is an example of a typical test. Given the flow is running and I tap save text, then I see success text. Very primitive one, but you have got the idea. Then we use a code generating package called BDD widget test to have Dart tests generated out of this text. This package already provides a lot of implementations for standard actions like I tap text and verifications like I see text. And for unknown steps like the flow is running, it would just generate a Dart method stop where we would put our own implementation. I personally find this approach fascinating. If you're interested to hear more about the various ways you can apply BDD widget test in your project, check out this series of YouTube videos. Because for us, it gave a possibility to write widget tests that cover not only the UI, but all the code in the package, which are not tightly coupled to the implementation details, and which is more important, they focus on requirements and are readable for non-technical members of the business area. Now, as I mentioned, we also have an extensive design system in its own package, and this one is covered with golden tests. Honestly, we also experimented with having golden tests for our features, but because they are slow and fragile and require significant maintenance effort, we decided to drop them. Anyways, because this design system is used across the app and is covered with golden tests, we can pretty much be sure that our features just look the same and correct. And finally, for the application itself, we write integration tests. So this is how we test our mobile products at Tide. Once again, for us, tests are mandatory. So whenever you change any piece of functionality, you must either add a new test or update an existing one. And we rely on CI to validate that. Which actually brings me to the automation topic. So once you are ready to share your first contribution, you'll have to open a PR on GitHub, because our main branch is protected from accidental or even intentional pushes. So we have configured a bunch of GitHub actions to run on each PR to perform code quality checks. And I will only highlight a few of them. First, we run Flutter analyze to make sure that new code has no warnings. And there is an interesting trick we apply here and actually in many other actions. You see, running Flutter analyze on the entire project will take unacceptably long, honestly. And it is because of the number of the packages we have, which may sound like a downside to this approach, but honestly, it's because we have so many little packages, we can actually easily detect a list of packages that was affected by this PR and packages that depend on those packages and run the check only on that set. This takes much less time, of course, depending on the set and kind of packages that was changed. And we apply the same approach to tests. Running tests in each and every package in our project would take up to 2 hours. However, we can only run tests for packages that changed and packages that depend on them, because naturally it doesn't make sense to retest the code that was not changed. And we have many additional actions implemented. Just to name a few, we have to check whether new third-party libraries have appropriate licenses. We also check whether the PR does not introduce new unused code or unused dependencies, and for example, that there are no new circular dependencies being introduced. And once again, this is where Melas tool really comes handy. Overall, we aim to automate as many checks as possible, but at the same time, they have to take a reasonable amount of time. And staying on the automation topic, we also need to talk about the release process. First of all, we have implemented the possibility to create ad hoc builds from any branch for any environment, like VIP or staging, or for any flavor, because we do build applications differently for UK, India, and Germany. So for that, once again, we're using GitHub Actions, this time in combination with Fastlane scripts. And these scripts are responsible for build number incrementing, providing configuration specific to the environment and flavor, removing native dependencies that don't have to be in that particular flavor, packaging and signing up bundles, doing some other magic, and finally uploading the builds and symbols to Firebase distribution for internal testing or to application stores for production builds. We make production builds on weekly basis, and after a few days of internal testing, they actually are gradually rolled out to all users, which brings me to the production maintenance. Having a finance app with 1 million of registered users, we clearly must be aware of any issues the moment they happen. So we use a couple of tools dedicated to monitoring and maintenance. For example, Datadog. It allows us to monitor all builds in real time with custom dashboards. And also it provides session tracking, which helps us to investigate any issues in production. We also use LaunchDarkly. It's a remote feature flags tool, and we use it not only for A/B testing, but we also control the availability of specific parts of the application. So if a problem is detected, we can quickly put only certain features under the maintenance mode and allow users to use the rest of the application. And of course, it's hard to imagine a modern Flutter application without Firebase, which we use primarily for crash monitoring, but also for analytics. But our main analytics tool is Segment because it supports integration with a variety of other analytics services. And we also have a few automations here done thanks to these tools. For example, whenever there is a new Firebase crash detected, we receive a Slack message in a dedicated channel. So that's all I have for today. We spoke about our team, codebase structure, discussed project architecture, testing and automation strategy, and I shared a list of tools and approaches we use for development and production maintenance. Hopefully, I inspired you to apply some of these techniques in your project, or encouraged you to question some of the practices that you have already adopted. If you have any questions, you can ask them now or find me at the conference venue. Thank you.